Good morning, and as we continue with our geometry lessons, we're going to talk about defining terms. And I just want to begin again by saying that this video and these instructions are meant to supplement my classroom instruction, and then for those students who aren't present, but it's not an all-encompassing lesson. It's just merely highlighting the things that we're working on today in class. So as we talk about defining terms, how can undefinable terms be used to create precise mathematical definitions? So we talk about these mathematical concepts. So mathematical definitions must be precise in language. They must provide sufficient information and include only necessary information. So as we begin here with a ray is a part of a line with an endpoint that extends forever in one direction. So let's see, in one direction. So it's part of a line. So let's see, we have a line. And if I want to label some points on here, let's go with A, B, C. And it says that it extends forever in one direction. So that means we have a starting point. For example, if we have ray B, C, and it extends forever in that direction. So we would write that as ray BC, because B is its starting point. That's why the arrow points in that direction. Now, if we were to turn around and say we have ray, how about AB? So starting off at ray A and then continuing on forever in this direction, that would look something like ray AB. And then if we had ray BA going off in this direction to the left, that would be written as BA and my ray, because the starting point was B and then we passed through A. So just being able to look at how would we write a ray and then what it looks like. Continuing on with a line segment. Now, a line segment is a piece of a line with two endpoints and a specific length. So if we start here and we use the same general information, a line segment is going to be, let's see here, a line segment will be drawn with a line over, and we need two letters. So if I said line segment BC, so it starts at B and ends at C. I could also write that as line segment CB, because it could go either direction, it doesn't matter, but we do have a finite start and stop point, because it has two endpoints. Another example might be segment AB, so we have segment AB, and then another might be segment AC, so that would be segment AC. And again, that could be written as segment CA, and this one could have been written as segment BA. Again, two endpoints on a segment. It has a specific length because it has a starting and a stopping point. So if we look at some examples, and it reads, identify the rays and line segments shown in the diagram. So here we go. Here's our diagram. And it looks like we have a plane right here. We have point C extending off into a ray here. So we have ray CD extending off in one direction. And then we also have this line here. And, you know, again, a line is going to be, we can break a line up into segments, and we can also break a line up into rays. So looking here at some of the rays, so I'll give you a minute. Let's see. What can we say? That we can say that we have ray CD, starts at C and extends through D. We also have ray, I could say that I start at point F and I extend through D. So I have ray FD. I could also say that that ray extends through E, so I could have said I have ray FE. All right, let's see what else. Get those off there. I could also say, let's see, if I started at D and extended down through F, I could say that I have ray DF. And as you can see, there is a difference between ray DF and ray FD because they're going two different directions. In FD, my starting point was point F. In ray DF, my starting point is point D. So just some considerations there. And then let's see, line segments. Line segments. Well, I can see that I have segment BA. I have segment AC. I have segment ED, just to name a few, and I have segment DF. Oh, I forgot my line here. And I'm going to go ahead and fill in a few more real quick. Now, I may not have all of those completed, but I was able to fill in a few more, and you may notice some on your own, but I think I may have gotten them all. So if you take a moment to look at these, you can see that those should all be independent rays and line segments. And of course, for the line segments, I did not use the reverse of the item, and which would be BA could also be AB when I'm talking about reversing the direction, where rays are very directional. Let's see here. So parallel lines are lines on the same plane that parallel lines on the same plane. They do not. That do not intersect. And that was one of the things we learned in algebra, that we had lines on a coordinate plane that would extend forever in both directions. And if they were parallel, that meant that they had the same slope and they did not touch. So that's how we would draw two lines. If I had line L and I had line M, and they were parallel, I would use these parallel marks here, indicating that they are both going in the same direction and they are parallel. These other lines are going to be, let's see, blank lines are lines that intersect at 90 degrees or a right angle. And that is going to be my perpendicular. Perpendicular lines. So lines that intersect at a 90 degrees. So I could have here, I have these two lines like my coordinate plane, and I'll just, I'll call this line N and this line P, and they would intersect at a 90-degree angle, and that would make them perpendicular. So that is my right angle indicator, which we know is 90 degrees. So looking here at example number 2, it says, are there any parallel or perpendicular lines in the diagram? And let's see, if you can't see this well on your paper, I do want to show that right here, these are my parallel lines and my right angle indicators. So if I'm looking for parallel lines, any lines that have this little arrow means they're parallel. So I have this line is going to be parallel to this line. So it looks like, let me see, I have line AB is going to be parallel, and that's how you would draw parallel, two straight lines. That is going to be parallel to line CG, okay? And then we have a perpendicular line, and we see here that line CG is on plane X, and it is parallel to line AB, but it looks like it is perpendicular to line RS. So we would show that as, oops, let's see here, we have line CG is going to be perpendicular to line RS. Okay, so there you go. We were able to find those perpendicular, and that's how you would indicate parallel lines, perpendicular lines. Let's see here. We could also say, didn't ask us, but if you notice, we have plane X right here. Then we have plane Y right here. And those two planes, plane X and plane Y, intersect at this line, but that line is currently unidentified. So Just looking at some of these geometry things as they roll together. As we look at angles, okay, continuing on with these defined notions, concepts, an angle is formed by two rays with a common endpoint. A common endpoint is called a, forgot I had the pen on, that's my vertex, okay? So if we look over here at this, we have an angle, and this is angle ABC, and this is ray BA, this is ray BC, and the vertex where the endpoint, the common endpoint, is going to be point B. And then the angle is named using 3 letters, and the middle letter must always represent the vertex. So if I were to write that, I would say that I have, again, angle ABC. B representing the vertex, it is my middle letter, and I could also say that I have angle CBA. B is still the vertex, but those are the same angle and how they are represented. Sometimes later on in math, you will see that just written as angle B. And that would tell me that when all of those are referring to this value right here, which is inside the angle, right? The angle, the degrees are inside the angle measurement. They're not the side links, they're inside. It's that space right there. It's the point from right here to right here is 60 degrees. And referring to a measure of an angle, we will always use a lowercase m. So in this case, I could say that the measure of angle ABC is equal to 60 degrees. So referencing angle ABC, this is telling me that the measure of angle ABC is 60 degrees. So they're just identifying the number attached to it in that sense. So looking at my angles, I'm hoping that some of this stuff is old news for you. Okay, so again, I hope this is old news. We have an acute angle, obtuse angle, right angle, and a straight angle. So an acute angle it's just a cute little fella. It's less than 90 degrees. So this is theta, which stands for the angle. So we have theta, which is my angle. The angle is going to be greater than 0, but less than 90 degrees. And that's how we would represent that. So it's less than 90 degrees, but it is greater than 0, because if it was 0, then it wouldn't be an angle. So that's why it has to be something greater than 0. And we'll talk about this more in class. Here, an obtuse angle, or well, let's skip over here to my right angle. After I get to, I'm less than 90, but when I get to 90, that becomes a right angle. So a right angle is an angle measurement of 90 degrees, and there's that perpendicular, that 90-degree right angle indicator. Then after a right angle, we can come over here to an obtuse angle, because this obtuse angle is going to be greater, remember theta angle is going to be greater than 90 degrees, but less than 180 degrees, because when we get to 180 degrees, we come over here and we have a straight line. 180-degree angle is a straight line, and we call that a straight angle. So again, this should be familiar to you in a sense that it's not completely unheard of, because we have worked with these things in earlier math classes. Let's see here. So as we talk about these, we're going to talk about the vertex, the sides, the names, and the classifications. But I'll just begin here by looking at, this is my center point of the common point of both my sides, which makes it the vertex. This is the common point of both my sides on this angle, making this the vertex. So again, the vertex is the point that they both sides have in common, where my sides come together. So my vertex is going to be point K. And when I am talking about the sides, I have two rays, my sides of my rays, and they start at point K and they continue on through J, or they start at point K and continue on through L. Okay, so those are my sides right here, from K that way, from K this way. And the names, let's see, it said, let's see here, I have an angle measurement, an angle, and it told us that our vertex had to be in the center, so I could say that I have angle JKL, or I could have angle LKJ. Either one of those is going to be acceptable. And then last, I could just say that I have angle K. Those are three different ways that we could identify this angle. In classification, let's see, I hope we can look at that and say, is it acute angle? No, it's not small. We don't have a right angle indicator, and it doesn't appear to be a straight line, so that should make it an obtuse. It's an obtuse angle. Okay, and then looking over here at this other one, this one I can tell you, look, real quick, what does that indicate? That indicates that we have a 90-degree angle. So this classification is going to be a right angle. And I'm going to do this when I'm talking about angle so it's quicker and easier on us. The vertex is going to be the point that they both sides have in common. So we have the vertex is point S. My sides, well, I start off here at S and I go through T. I start off here at S and I go through R. So my sides are going to be ray SR and ray ST. How to name this? Again, we have this center point vertex, so we could say that it is angle S. We could also say that it is angle RST because our vertex has to be in the middle of those three letters, or it could be angle TSR. All indications, though, remember that we have our vertex in the center. So with that, let's see, what else do we have? Oh, let's see here, blank. A blank is defined as all points in the same plane equidistant from a given point. Ah, good, a circle, right? So we have this point, it says a circle, right? A circle is defined as all points the same distance on the same plane equidistant from a given point. So we'll call this point, no, don't want to use that one. We'll call it point Q, okay? So as point Q, now if I take this and it's going to be hard to do a circle because I'm a horrible drawer. Okay, so please assume that that circle is just awesome and perfect, and that every point along this circle is going to be equidistant from the center of the circle. So this point, this is called my radius. Radius goes from the center of the circle to the outside, and that's equidistant point. And then, so I would call this would be identified as circle Q, and then my radius is going to be my R, and then if I needed to have a diameter is what goes all the way through the circle, goes from one edge of the circle to the other edge of the circle, passing through the center. So that would be considered my diameter. And I will tell you that D is equal to 2R because I have 2 radius would equal the entire length of D. So just some characteristics of a circle. And then we talk about the arc, and the distance around an arc can be measured when given specific, I think we're going to shoot for endpoints here, right? So if I look at a circle and I have here point A and point B, those would be my endpoints of an arc, because the arc would be the distance from point A to point B along the edge of the circle. The circle's arc can be measured in in any unit of measure for length. So it may be, again, we sometimes forget to talk about the units of the size of something. It could be inches, could be centimeters, could be miles. If you're talking about the surface of a planet, or an ellipse, or those kind of things. So sorry, didn't mean to mention ellipse. But yeah, so a arc is going to be that length of measure along the circle's circumference. So looking here, looking at example number 3 as we go to do some identification, I can tell you, let's see, it says name the vertex of angle 2. Well, here is angle 2. Angle 2, the vertex, its common sides are right here. So its vertex, this is point T. It's going to be point T, and it says name the sides of angle 4. Angle 4, its sides are going to be ray TV and ray TW. So ray TZ, sorry, and then ray TW. And then write another name for angle 3, which is right here. And that is going to be this angle is angle 3. And it could be either angle UTZ, or it could be angle ZTU. And what you'll notice is the vertex is going to be that center letter. And then write another name for angle 1. Okay, doing the same thing, angle 1 here. Have this, and that is going to be angle measurement, or angle, YTX, or it could be angle XTY. Classify, talking here now as we look at a couple more examples, it says classify YTW. YTW is going to be, it looks like YTW is right here. It is going to be 90 degrees. So that makes it a right angle. Classify YTU. YTU is right here. YTU is not a straight angle. It's not a right angle, so it must be an obtuse angle. Then we have XTU, XTU, and it looks like that is an acute angle. And then we have WTX, WTX, and WTX is a straight line, so that makes that a straight angle. Name 2 perpendicular lines. Okay, again, looking at some of this information. I have 2 lines. This is my perpendicular indicator, 90 degrees. So I have line YZ is perpendicular to line WX. So line YZ is going to be perpendicular to line WX. And let's see here, this final question is name an angle bisector. And we have not really discussed bisector at this point. But what a bisector does is it cuts something in half. Okay, and what I can see here, that if I have this big angle, I have XTZ, and an angle bisector might be TU here, because it seems to cut this angle in half, because this angle is equal to this angle. So we'll talk more about bisectors in the future, but I can say that is one example. Ray TU is an angle bisector. There are other examples on here. That just happens to be one of them that I've noticed. So again, there, as we talk about the terms that we are learning how to define and understand in geometry, we're going to take this and we're going to go ahead and work on today's assignment.